instead of you watching me type in all of the configuration commands, I just went ahead and put them in so that we can just get right to the troubleshooting part of this thing. And I'll try to go through his troubleshooting steps. Starts on the Corp router here, and the first thing we do is to show, so we have adjacencies. That's good. That's telling us that we probably got something going here somewhere, right? These will show IP interface brief. And when we do that, we have the, as he has the 10.1.1 and the 192.168.1.1 networks configured on it. So on, and on this one as well as on yours, he's got 0, 0, 0. Yours are going to have the 0, 0.0/0/0 because in Packet Tracer, it's the only routers that I can find have those interfaces that actually support IPv6, and you have IPv6 lab also. So when we do this thing, the next thing he wants to do is, how did I get out of enable? Show IP interface brief. So I wasn't ever in enable. That's how I got out of it. So we want to ping 192.168.1.2, which is the other end of this thing, and it works. And then we're going to ping 10.1.1.2, which is the other end of it. So we're talking between routers. We have what this tells us is here, this up says that we have a good physical connection and a good layer 2 connection. Our encryption, our encapsulation protocols are the same on these things. So the next thing he wants to do, we're going to get to the problems here in a few minutes. OSPF interface 0/0/0/0. When we do that, 192.168, the hello due in 9 seconds. So we're getting hellos on this thing. Suppress hello for 0 neighbors, the hello and the dead timers. The hellos is still the 10 and the dead 40. And again, hello is, this is how frequently hello packets are sent. The 40, the dead timer 40 is how long we'll wait before we say that a network isn't there anymore. The cost is 64. The point-to-point, the cost on his in the book is 100. That's based on the bandwidth that's configured on these things. The process ID and the router ID. The process ID is one. The router ID 192.168.1.1. And again, that's if we go back to the show IP interface brief. IP interface brief. Then this 192.168.1.1 is the highest IP address that's on this router. Hence, it's going to be its router ID. And then he wants to do the same thing, show IP OSPF interface gig 0/0. When we have these things, we're going to go through a whole lot of the same thing. The cost here is 1 because this is a gigabit connection. Cost 1 for high speed. And OSPF uses cost to calculate the route. So the router ID is still 1.1. Transmit the state DR. Remember we talked about for the multi-area ones, and this is connected to a switch, think Ethernet. We're going to have a DR and a BDR. So this one, 10.1.1, so it is going to be the DR, the delay on this one. Oh yeah, that makes sense. It's a 1.1 and the other one doesn't have a 192.168 on it. I didn't want to do that, did I? Let's get back to this guy. So, show IP OSPF neighbor. We have one neighbor. We're in full, and that neighbor is the BDR. Its address is 10.1.1.2. And again, the one we're on is going to be the DR because its highest IP address was 192.168.1.1, and the other one is 10.1.1.2. 192.168 is higher than the 10.1 address. Let's see what he did. I thought. Anyway, we got the neighbors, and then we're going to show. Oh, I know what he did. We're going to show IP protocols. When we do that, you notice that this thing has an EIGRP network running on it. This is the one where I'm not sure that he did all these things actually in sequence, because if you look in the book, his show IP protocols doesn't have EIGRP running on it. And the only way I know to get an EIGRP route is to actually have the protocol running someplace else. I guess that I know how I could have done this, but I didn't, was to put another router out here with EIGRP on it, and then we do it. Because what we're doing is a redistribution of routes into OSPF, and I'll show you that command on the other router here in just a second. So show IP route. When we look at these things, we have a D, and you notice that the administrative distance here is 90. And we're only getting EIGRP routes here because everything else is connected together. It already knows how to get to the 10.1 network when we do these things. Actually, he's got the, let's see, we'll go to the branch. Go to the branch router, and this is the one where we wanted just to have the show IP route, can't spell it. And we still have the D to get to 10.1.1 via 192.168.1.1, which makes perfect sense. The L's, remember again, are actually for IP addresses. These are local on that particular network. If we show IP protocols here, we're still going to have EIGRP 20. We have all those things that we had with it, and then we have OSPF 2 running on OSPF 2, the number, the OSPF number that's on this thing. Losing my mind. The router ID 192.168.1.2, because again, it's going to be the highest one. It's routing for networks 192. So what we're saying is we have OSPF running on it. It's routing for all the networks that are here, but we're not seeing any OSPF routes. The reason we're not seeing those is because we have EIGRP running on the routers, and EIGRP has a lower administrative distance, which means it's more trusted. So what this shows you is that you can have multiple protocols, but you are, if they're running advertising the same networks, you'll only get the one that has the lowest administrative distance. If I were running EIGRP and advertising different networks, writing for different networks, then, and I'll see if I can set this up, what we would do is what's called redistribution. And what we do is, I told you I like to do the show run first. We go to the router OSPF 2. It has all of its other stuff, and redistribute EIGRP 20 and its subnets. What that's saying is, since EIGRP and OSPF are not the same language, kind of like two people in a room, one speaks English and one speaks Chinese, they don't understand each other. What this is saying is translate the EIGRP routes and then send them out OSPF. So we can have the same protocol running there. What realistically, and again, I'll try to set one up and do a little video for you if you really want to see it, is this guy, we could put an EIGRP router out here that goes someplace else, and then we could send those EIGRP routes to OSPF, and then they'd get sent downstream back here to the internal and to the corp router. So that's where I said it doesn't always do exactly what he wants to do there. You also notice while we're here, and this is why I like to do this, and then if you go through his process, we also have a passive interface. Passive interface is going to keep us from using that OSPF information. But let's do these things one at a time. First, let's get rid of the EIGRP 20. Because if we get rid of that, no EIGRP 20, no How about router EIGRP20? Would that probably work better? No. Oh. Maybe it's IPGRP. What's the command? It's router IPEIGRP20. That's router EIGRP, right? Config T. No router EIGRP20.
Put 10.
Well, probably if I spell EIGRP, I type slower. If I put EIGRP, I know it's 10 in the book, but it's actually 20 on this thing. So if we do, well, it's not going to be there anymore. But when we looked at it, it was, we'll go back up here. It actually in the configuration was 20. Okay, so that's one. But it helps when you spell EIGRP correctly. Actually, it did it here, and I didn't realize what it had done for me. But anyhow, now then, Control Z, show IP route. We still don't have anything. And we'll come back to this one. Let's go over here. The EIGRP neighbor is down. The hold time expired. And that's what you're going to get. That's the message that you're going to get when the hold time, dead time, expires. It's called hold time in EIGRP and dead time in OSPF. Show IP route. And again, we don't have any route. So I think what he wants us to do on that, which one is that on? It's on this guy, right? Is show IP interface. Actually, let's try show IP protocols. When I show IP protocols, what it's running for, it's a boundary router, the router ID, redistributing external routes from EIGRP20. See, that's why we can look on down here. It says it's got a passive interface. We could have looked at the interface and it would tell us that too. Some of these summary commands actually help you out. So we have serial 000 as passive interface. So we need to go to, and it's OSPF2, right? Config T, router OSPF2, no, passive interface serial 0/0/0. Is that right?
Mm-hmm.
Control Z. Now with any luck, yeah, there we go. Now we're up. Now we have our adjacency. And you notice it says it goes from loading to done, and we could show IP route, and we have our OSPF, and we have our area route, which says that this network is in a different area, and it is in a different area because we have area 0 and area 1 on this thing. With that said, and again, my troubleshooting, I really like to start, and we could have solved most of what the book did configuring these things. It's a lot of fun configuring these because I got to go through them and say, okay, what did he, could have find something that he did. What did he do wrong as he undoes it? But the show run gives you an awful lot of information. You can look at all that other stuff. The timing, if you have mismatched hello timers and dead timers, you really need to look at the OSPF for that, because that's probably not going to, I don't think that doesn't. I know that doesn't show up in there. So the things that are specific that can be modified that have to match, you have to look at the protocol to see what's going on with that. With that, that is the troubleshooting one from this chapter. Questions?